Hey everyone, welcome back to the channel. If you are a developer or architect working with microservices, Docker, or Kubernetes, you have possibly heard of 12-factor application, a set of golden rules for building scalable, cloud-friendly softwares. But here is the thing, this 12-factor app model was out in 2011, and since then, the world has changed dramatically. We now have serverless computing, event-driven applications, DevOps, and multi-cloud deployments. So today, I'll take you beyond the original 12-factor app to the 15-factor app, an upgraded modern framework for 2025 and the years beyond. And we'll also cover each factor with simple explanations, examples, and practical tips. So let us dive in. So, the 12-factor app was first introduced by developers at Heroku to help teams build applications that scale easily and deploy anywhere. It is kind of a time-based foundation, but in the age of Docker containers, Kubernetes, AI-driven pipelines, and distributed systems, developers needed more. So engineers and cloud architects started evolving it, adding 3 new principles focused on security, observability, and graceful evolution. And that's how we got the 15-factor app, which is an enhanced model that helps you build resilient, observable, and secure modern applications. Alright, so let us start with the 12-factor app, then we can explore the added on 3 new factors. Okay, so the original 12 factors started with step number 1, code base. So one code base, many deploys. Ideally, every application should have one single code repository per microservice. Multiple environments, dev environment, QA, prod, should all come from that one source. For an example, a GitHub repository that deploys both staging and production using separate pipelines. Step number 2, dependencies. Declare them explicitly and never rely on global installs. You can use packages like Maven, Gradle, NPM, or PIP to declare dependencies based on your choice of language. For example, package.json, it lists React, Axios, and Jest, so any developer can just run npm install and install all these dependencies. Now the number 3, config. Store configuration in the environment only, and never hard code secrets or database credentials in the application. Always store them in the environment variables or secret stores. For example, variables like database URL or any Kafka host. You should always use these variables in the Kubernetes secret or environment variables. Step number 4, backing services. Treat external services as attached resources. For example, databases, caches, or messaging queues should always be replaceable and not hardwired into the code. For an example, your app connects to AWS S3 or let's say Google GCP storage through an environment variable, not a fixed endpoint. Because fixed endpoint might change in the future, and if you are using an environment variable, then your code is resilient to the changes. Now, let us talk about number 5. Build, release, and run, and keep these stages separate. Your CI/CD pipeline should have clear separation. Build, which is about to compile and package, release to attach configurations, and run, which actually execute in the production. For example, like Jenkins builds a jar, GitHub Actions injects secrets, and Kubernetes runs the applications. Now let's talk about number 6, processes. Execute the app as stateless process, and you should always avoid storing session data in the memory. Your app should be stateless and share nothing. For an example, like you should always store sessions into the Redis cache instead of a local memory, so multiple pods can share this particular data. Now let us talk about number 7, port binding. Export services via port binding. Your app should expose itself over a port, and it should not depend on an external servers like Apache. For an example, a Spring Boot application starts on port 8080 and is accessible directly through Kubernetes ingress. Step 8. Concurrency. Scale out using the process model, handling high loads by adding more instances instead of adding more threads. For an example, you can use multiple containers behind a load balancer instead of one overloaded instance. Number 9. Disposability. Fast startup and graceful shutdown. Your application should boot quickly and handle restarts gracefully. A Node.js application that initializes within seconds and catches sick term to finish pending request before shutdown. Number 10. Dev prod parity. You should always keep the environment consistent. Your dev environment, staging environment, and prod environment should always look the same. For an example, you can use Docker Compose locally and Kubernetes in production, same images, same config to get the application up. Step number 11. Logs. Treat logs as event streams and do not store log files into your application. You should always write logs to Studio Out or any, like, you can use any third-party platform to handle them. For example, Log4j, etc. Number 12. Admin processes. You should always run admin tasks as one-off jobs. For an example, database migrations or maintenance activities should be temporary jobs and it should not be part of your running application. Now let us talk about the 3 new factors that were introduced. And these 3 new pillars that make application truly cloud native and enterprise grade today. The number 13, API first. Design APIs before designing the code. Modern systems talk to each other via APIs. It can be REST, GPRs, gRPC, GraphQL. By designing your API first, you ensure that every service can evolve independently and teams can work in the parallel. For an example, you can use Open API, which is also known as Swagger, specs before writing the actual code. Front-end developers, they can start using mocking these APIs while backend logic is still being built. The benefit is that you can get the predictable integrations and the teams can collaborate faster and the changes will not break later. Number 14. Telemetry. Build for observability. You cannot improve what you can't measure. You cannot improve what you can't measure. Applications today must expose metrics, traces, and logs for visibility. You can use Prometheus for metrics, Grafana for your dashboards, and Open Telemetry for tracing. And what are the key metrics you should look out for? Latency, which is also called response time. Then we have error exception rates, request throughput, and the resource utilization. And what is the benefit of this? So basically the benefit is that you can detect the issues before users are affected by these issues. Now let's talk about number 15, which is called security. Bake security into every layer. In 2025, cloud security is not an optional, it's foundational. Security must be built into your code, pipeline, and infrastructure. For an example, you should always scan Docker images with any of the Trivy or any other like scanning. You can use HashiCorp Vault for secrets. You can use automated dependency scanning with SNCC or OWASP dependency check. You can enable HTTPS, JOT, and encryption by default. Security isn't a patch, it's the part of your application. So there you go, the 12-factor application, which is kind of a modern evolution of Heroku's 12-factor design for today's distributed multi-cloud world. So let's recap quickly. The original 12-factor taught us how to build scalable, portable, and cloud-ready application, and the 3 new factors, API first, telemetry, and security, and make them observable, interpretable, and safe in production. If you are building microservices, serverless systems, or containerized app, embrace these 15 principles and they will make your software faster to deploy, easier to maintain, and ready for anything the cloud infrastructure throws at you. And drop a comment below. Which factor do you think developers ignore the most in the real development cycle. And if you found this breakthrough helpful, hit the like button, subscribe and share this with your team, because the future of great software isn't just about code. It's about applications, it's about architectures that scales well. Thanks for watching, and I'll see you in the next video.